Vanakkam students, and welcome. So today, we're going to unlock one of the most powerful tools in all of calculus. Seriously, this is a technique that can take super complicated differentiation problems and make them, well, pretty simple and easy to manage.
Okay, so let's just start with a challenge. In differentiation, sometimes you come across functions that look like the final boss in a video game. They just look really intimidating and complex.
Just take a look at this one. Y equals sine x to the power of log x. It looks pretty scary, right? Now just think about it for a second. You can't just use the standard power rule, because the exponent isn't a constant number. And you can't use the exponential rule either, because the base isn't a constant. So what do? Where do you even start?
Don't worry, for these kinds of monster functions, we have a secret weapon. Think of it like a special power-up that completely changes the game.
And that secret weapon is called logarithmic differentiation. The best way to think about it is like a special filter you'd use on an Instagram photo. It simplifies everything before you even start the main work, and that makes the whole problem way easier to handle.
So what is the secret here? How does this even work? Well, it all comes down to the magic of logarithms. Logarithms have these three special properties. Let's call them superpowers that can turn really tough problems into much easier ones.
And this table here just illustrates that magic perfectly. Look at this. The product rule turns difficult multiplication into simple addition. The quotient rule turns a messy division problem into clean subtraction. And the best one of all, the power rule, it takes those really scary exponents and just brings them right down, turning them into simple multiplication. This right here, this is the key to everything.
So, we can actually turn this magic into a simple, repeatable strategy. It's a 4-step game plan that you can use to solve any of these complex functions, every single time.
It's really that simple. Step 1, you take the natural log of both sides. Step 2, you use those magic log properties to simplify everything. Step 3, you differentiate both sides. And finally, step 4, you solve for dy dx. Just follow these 4 steps, and I promise you, even the most complicated-looking function becomes super manageable. You can definitely do this.
All right, so theory is great and all, but let's see this thing in action. We're going to look at 2 main types of problems where this method is an absolute lifesaver. Let's start with the first one and see how our 4-step game plan helps us win.
Let's begin with a really messy product and quotient function like this one. Seriously, can you even imagine trying to solve this with the normal quotient rule? You'd have to use the product rule inside the quotient rule. It would be a long, messy nightmare with so many places to make a small mistake.
But with our magic trick, we just follow the plan. We take the log of both sides, and poof, just like that. The messy product on top becomes a simple addition, the division becomes a subtraction, and that square root turns into a simple 1/2 multiplier. The problem is already so much simpler to look at.
And now we just move on to step 3 and 4. We differentiate each of these simple parts one by one, then we isolate dy dx by multiplying the whole thing by y, and that's it, we're done. See how much easier and cleaner that was? No comparison.
Okay, now for the main event. This is the type of problem where logarithmic differentiation isn't just helpful, it is absolutely necessary. A function raised to the power of another function. You can think of it like a viral TikTok remix. The original audio, that's our f of x, and your new video, that's our g of x, are both changing and interacting with each other at the same time.
So let's apply our game plan. We take the log of both sides, and that super powerful variable exponent, it just comes right down in front. Instantly, the problem transforms from a power into a simple product. This is the most important step right here.
Now for step 3, we differentiate. The left side is easy, but you have to remember the chain rule. It becomes 1 by y times dy by dx. For the right side, we now have a simple product, right? X times log of sine x. So we just apply the product rule. This is so much easier to handle than that original power function.
And for the final step, we just solve for dy dx, we multiply both sides by y, and then, this is important, we substitute the original function for y back into the equation, and there it is, our final answer. You've just solved a boss-level problem with a clear, simple strategy.
You're doing great. Okay, let's quickly recap the most important points so you know exactly when and how to use this powerful tool.
So please remember this. You can use the superpower for those messy product and quotient problems just to make your life easier. But you absolutely must use it when you see a function raised to the power of another function. For f of x to the power of g of x, this is really the only way.
In this step, Ladam, most students get confused. But here's the trick, so you'll always remember. When you differentiate log y with respect to x, you are using the chain rule. So it is always 1 by y multiplied by dy by dx. Do not forget the dy by dx part. This is the single most common mistake people make.
Okay, here is your quick revision guide. Just remember these points. Use it for complex products and especially for those function-to-a-function powers. Follow the 4 steps. Take logs, simplify, differentiate, and solve. And please never forget that the derivative of log y is 1 by y times dy by dx. If you master this, you have mastered this topic.
Avlo, dhyan, that's all. Logarithmic differentiation is actually much easier than it looks, isn't it? You have now added a very, very powerful tool to your maths toolkit. So keep practicing with different functions and you'll become an expert in no time. All the very best.